Hello everyone, Namaste. Welcome to Vicheth Chemie YouTube channel. This is Vidyashri. I hope you are all doing well. In this video, I will be discussing the important points on the chapter 5 of 8th standard mathematics, squares and square roots in regard to the preparation of teachers eligibility test. Either it may be Karnataka teachers eligibility test or central teachers eligibility test. Those who are all preparing for paper 2 mathematics on teachers eligibility test can make use of this video. Please note that in this video I will be explaining the contents only in English, and those candidates who are appearing for these exams in Kannada medium, a video on this chapter in Kannada has already been created by me and I have already uploaded it on YouTube. The video link will be provided to you in the description box below this video. The candidates who are preparing in Kannada medium, please do check out that video and make use of it. Now, without delay, I'll let you know what are the important points from squares and square roots. Here, first of all, you need to know that what are these square numbers and how we are going to get these square numbers. Okay. So, the numbers which can be expressed as the product of the number with itself. Such number we call it as square numbers. To find square of a number, we have to multiply the number by itself. So you can check out here, to find the square of 1, we have to multiply 1 with itself. So we get square of 1 as 1. And square of 2, yes, 2 into 2, that's 4. Similarly for other numbers. In general, for a number a, if you multiply a with itself, you are going to get square of a. So, the numbers which can be expressed as the product of number with itself are called as squares or square numbers. And the numbers such as 1, 4, 9, 16, 25 are known as square numbers. So now, in general, to say generally, if we consider a natural number m which can be expressed as n square. So where this n is also a natural number, then we call m is a square number. So you consider two natural numbers m and n, where if we can write m as n square, we call m as square number. I hope it's clear. So now we got to know what is a square number, example for it, and how do we get a square number. We can get a square number by multiplying the number with itself. The numbers 1, 4, 9, 16, which we just called it as square numbers, are also called as perfect squares. So square numbers are also called as perfect numbers. Now let's move on to study the properties of square numbers. Now let's make a note of important points on the properties of square numbers. Here in this table, you can note the squares of numbers from 1 to 20. So it's better for you to memorize the squares of all these numbers from 1 to 20. At least from the numbers 1 to 20, you have to memorize the squares. That would be of great help for any competitive examinations. So here you have squares of numbers from 1 to 20. Just carefully observe with respect to the number as well as its square. Okay. Then we can come to a few conclusions. Now let us try to check out what are all these conclusions which can be made with respect to these square numbers. So nothing but we shall be noting down the important points with respect to properties of square numbers. Whatever I am explaining the points, you can identify that from this table. If you observe carefully from this table, you can make out that all these square numbers, they end with 0, 1, 4, 5, 6 or 9 at unit places. So all the square, they ends with 0, 1, 4, 5, 6 or 9 at its units places. And none of these numbers ends with 2, 3, 7 or 8 at units places. So if you check the square numbers or perfect squares, its last digit means the units place, digit at the units place, they are either 0, 1, 4, 5, 6 or 9, and none of the perfect squares end with 2, 3, 7 or 8 at its units place. So from this what we can make out, any number whose unit digit is 2, 3, 7 or 8, it cannot be a square number. Then from the other numbers which ends with 0, 1, 4, 5, 6 or 9, they can be square numbers. So this is the first point that you have to note. Okay. So from this we can check whether the given number can be a square or it cannot be a square. Again here you have a table. From this table again you have squares of numbers from 1 to 10, 11 to 20 and from 21 to 25, then 30, 35, 40, 45, 50. So if you memorize all these squares, that would be very good and helpful for you. Now let's proceed further to know about the next properties. So now you just check the square numbers that's ending with digit 1. Okay. 1, 81, 121, 361, 441. So the numbers from which we get these square are 1, 9, 11, 19, 21. So from this what we can conclude is that if a number has 1 or 9 in its units place, then its square ends in 1. If a number has 1 or 9 in the units place, then its square ends in 1. So that's what you have observed from this number and its square. Here we have number whose units digit are 1 or 9, either 1 or 9, and their squares are ending with 1 in their units digit. So this is the second point that you have to note. Proceeding further. Now here you check the square numbers ending in 6. So if you check that, you can make out that if a number has 4 or 6 in its units place, then the square ends with 6. So if any number is having 4 or 6 in its units digit, then the square numbers are ending in 6. So here you go. When a square number ends in 6, the number whose square it is will have either 4 or 6 in its units place. Similarly, what else you can make out from the table is that the number ending with 0 and 5. If you have 0 at the units digit and 5 at the units digit, in the square itself you will find the same thing. 0 will be there in the units place and 5 will be there in units place. And what thing you have to note that with respect to the numbers having 0 in their units place and tens place or hundreds place, if you have 1 0, then the square number will have 2 0. So you can check with the same with 10, 20, 80 and so on. 10 square is 100, 20 square is 400, 80 square is 6400. Where all the numbers are having only 1 zeros, but their squares are having 2 zeros. Now, here you can check with the numbers which are having 2 zeros. 100, 200, 700, 900. Now their squares will have 4 zeros. Okay. So you can tell that you will not find odd number of zeros in a square number. Okay. Always you will have even number of zeros in a square number, or you can tell that a square number will have only even number of zeros. So we can say that square numbers can only have even number of zeros at the end. We can say that. Now in the table you have to check about the squares of even numbers and squares of odd numbers. So once you check, you will see that squares of even numbers will be even and those of odd numbers will be odd. So these are the properties of the square numbers. So all these points you should make a note of. So using all these points, you can identify whether a given number can form a perfect square or it cannot form a perfect square. Then we are provided with some interesting patterns related to these square numbers. First among that is adding triangular numbers. So you might be knowing what triangular numbers are. The numbers whose dot patterns can be arranged as triangles. Okay, such number we call them as triangular numbers. So here you see 1, 3, 6, 10, 15 are triangular numbers, where if you write these numbers in the dot form, you can arrange these dots in a triangular form. 1, 3, 6, 10, 15 are these triangular numbers. Now what we are going to observe is that when we combine two consecutive triangular numbers, we will get a square numbers. So just now you have written that the triangular numbers are 1, 3, 6, 10, 15. So if you add the consecutive triangular number, you are going to get a square number. Just check. You add 1 and 3, you are going to get 4, which is a square number. Add 3 and 6, you are going to get 9, which is a square number. The next consecutive triangular numbers are 6 and 10. Consecutive means the numbers which come immediately one after the other. Okay. So 6 and 10, you get 16. That's a square number. Then you have 10 and 15, which are the next two consecutive triangular numbers. You get 25, which is also a square number. 25 is a square of 5. The next pattern, interestingly, we observe is the numbers between the square numbers. Suppose you are asked to find how many numbers are there between the given two square numbers. Suppose you need to find the number of numbers which are present between the two square numbers 4 and 9. So we have to find numbers between 4 and 9. Okay, I'll just write here numbers between 4 and 9. How many numbers you have? 5, 6, 7 and 8. There are 4 numbers. So what is this 4? It is a square of 2 and 9 is square of 3. Nothing but consecutive numbers and they are squares. In between them we are going to find the numbers. Okay. So between the squares of 2 and 3 we have 4 numbers, right? 5, 6, 7, 8 are 4 numbers which we have. So it is between n square and n plus 1 whole square. So here our n is nothing but 2. Okay. So we have 2n numbers between n square and n plus 1 whole square. So now our n is 2. N square is 2 square. That is nothing but 4. Okay, that's what we have found. We have already calculated that we have 4 numbers between the perfect squares 4 and 9. Okay. So here you can make a note of this point. There are 2n non-perfect square numbers between the squares of number n and n plus 1. So this is what I have told you just now. Moving on to the addition of odd numbers. So here we can generalize that sum of first n odd natural numbers is n square. This is important that you have to remember. Sum of first n odd natural numbers is n square. Say suppose we are going to add the first 5 natural numbers, means odd numbers, sorry. First 5 odd natural numbers. Okay. So that's we are going to add first 5 natural numbers 1 plus 3 plus 5 plus 7 plus 9. So how many numbers do we have? We have first 5. So what is the value of n here? Since we are going to add first 5 numbers, n is equal to 5. So their sum is nothing but it is n square, which is equal to 25. So this is how you can find the sum of first n odd natural numbers. So you just have to remember it is n square. Sum of first n odd natural numbers is n square. In other way, we can also tell this that if the number is a square number, it has to be sum of successive odd numbers from 1. So if the number is a perfect square, then we can express that number as the sum of odd numbers starting from 1. Now what if we cannot express a number as the sum of odd natural numbers starting with 1? So we can tell that it is not a perfect square. Okay. So we can find out whether a number is perfect square or not by checking whether we can write the given number as sum of odd natural numbers starting with 1. Next we have is a sum of consecutive natural numbers. Now here if you consider square of any odd natural number, okay, for example you can consider 3 here. Consider square of an odd natural number. That square can be written as the sum of consecutive natural numbers. Say if you consider in general n is a odd number, n square can be written as sum of two consecutive natural numbers. So here I'll write where a and b are consecutive natural numbers. So it can be written like this. So now where I can write a is nothing but it is n square minus 1 by 2 and b is n square plus 1 divided by 2. So you just have to make note of this point. So this is how we can generalize on sum of consecutive natural numbers here. So if we have n is an odd number whose square can be written as sum of consecutive natural numbers, where you can find a as n square minus 1 by 2 and b is n square plus 1 by 2, where you can check this result for all these numbers. So what you can make note is that, so you can write, we can express square of any odd number as the sum of two consecutive positive integers. Next is the product of two consecutive even or odd natural numbers. Suppose if we consider two consecutive even or odd natural numbers. So if you are considering odd natural number, two consecutive odd natural numbers you have to consider, or if you are considering even numbers, two consecutive even numbers you have to consider. So then we can write those two odd or even numbers as a plus 1 and a minus 1. So then the product of these two numbers is nothing but a square minus 1. Now for example, I'll consider 11 into 13. So product of 11 and 13. So these two are consecutive odd numbers. Consecutive odd numbers. Now I need to express this in the form of a plus 1 into a minus 1. So here 11 I can write it as 12 minus 1 and 13 I can write it as 12 plus 1. So now I can write 11 as 12 minus 1 into 13 is 12 plus 1. So now it is in this form. So I can write this as a square minus 1. A is nothing but 12 here. So it is 12 square minus 1. So I'll write it here. So here we have a as 12. Now 12 square is 144 minus 1 is 143. So we find the product as 143. So which is here. So what we have found is true, right? It is 11 into 13, that's 143. So some more interesting patterns is also given on these square numbers. You can just check it if you are interested. So please do solve these exercise 5.1 so that you can just check how much you have understood or to what extent you can solve the problems on the matter how much you have practiced it. Okay, you can just check out your practice level. Next, moving on to know that how you can find square of a given number. Okay, So if you are given with a small number like 3, 4, 5, 6, 7, 9, okay, till 20, that's very easy for you to find square of a number. So just simply you will multiply the given numbers, or you just have memorized those square numbers so that easily you can write. Now for bigger numbers, how you can find square is a question. So just multiplying could not be easy in that case, right? So you need not multiply. So there is a different method which we can use, okay? Say for example, here 23 has been considered, which is written as 20 plus 3. Suppose if you have considered 203, you could have written it as 200 plus 3. So you should split that number in such a way that easily you could find square for both the numbers, okay? Now we need is 23 whole square. So we will square the number 20 plus 3 also. Then you make use of the formula a plus b whole square. So we have a plus b whole square is nothing but a square plus 2ab plus b square. Just make use of this formula, simplify and get the answer. So that's how you can find square of a given number. Now if a number is given to you in such a way that its unit digit is 5, okay? So now for example, you can consider a number with unit digit 5 and you are considering that number as A5, where 5 is the unit digit, A are the other digits, okay? Now how to find its square is that you will consider the given numbers A and its product with A plus 1, its hundreds you will consider and you will add 25 to that, okay? So you can just make a note of this as important, so that how you can find square of a number ending with the digit 5 very easily, okay? So here I'll consider this first example. They have found out the square of 25, okay? So I'll consider the number 25 whose square has to be found out. So here a is nothing but 2, okay? Now we need is a5's square, so which is written as a into a plus 1 hundreds. I'll write hundreds as h plus 25. A into a plus 1. A is 2, a plus 1 is 3. So we have 2 into 3 hundreds plus 25. 6 hundreds plus 25. So we have 6 hundreds to which we have to add 25. That comes out to be 625. So if you can check that square of 25 is 625. So this is how you can find the square of a number that is ending, means whose unit digit is 5 without multiplying it. Or else you should be doing 25 into 25. Or you should be using 20 plus 5 whole square. This is another way of finding square of a number whose unit digit is 5. And the next important thing that you have to note is the Pythagorean triplets. So this is very, very important. Understanding and remembering these Pythagorean triplets will be of great use for those who are all appearing for the competitive exams. Not only for teachers' eligibility test, the concept of Pythagorean triplets will be useful in other competitive examinations as well. So here what we have is a set of 3 numbers. Okay, we have collection of 3 numbers where sum of squares of 2 smaller numbers will give you a value which is equal to the square of the third number or the bigger number in the collection. I hope I am clear. You will have 3 numbers. Say here you have 3, 4 and 5. Okay, this is collection of 3 numbers where you have 3 and 4 which numbers are smaller than 5. Okay, now sum of squares of the 2 smaller numbers will give you a value which is also same as that of the square of the biggest number in the collection. Okay, such 3 numbers we call them as Pythagorean triplets. Another example for the Pythagorean triplet is 6, 8, 10, 5, 12, 13. So these numbers form Pythagorean triplets. They are called triplets because we have collection of 3 numbers here. Okay. So the examples are 3, 4, 5, 6, 8, 10, 5, 12, 13. Now how we can generalize this? Okay. So for any natural number m is more than 0, we have 2m squared plus m square minus 1 whole square is equal to m square plus 1 the whole square. So here 2m, m square minus 1 and m square plus 1 forms Pythagorean triplets. So you can just remember, you can consider any m and you will find the value of 2m, m square minus 1 and m square plus 1. So these numbers will form Pythagorean triplets. We have understood about squares. Now let us see how we can find square roots. Okay. So now if you are provided with a number, you know how to find its square, right? What you will do, you will just multiply the number with itself so that we will get square. Now what is this square root? Square root means the number from which we have obtained that square number, we call it as square root. Now if you check, 1 square is 1. So we can tell that square root of 1 is 1. 2 square is 4. Means 4 is a square number which we have obtained by multiplying 2 with itself. So we tell square root of 4 is 2. Similarly, square root of 9 is 3. Okay. Now similarly, if you check, 9 square is 81. Minus 9 square is also 81. So we say square roots of 81 are plus 9 as well as minus 9. So square root can be a positive number or a negative number. But square is always a positive number. And positive square root of a number is denoted by the symbol square root. Here in this chapter, they are solely focusing on the positive square root for a given number. Here now, in these two tables, you can check the square for a number as well as square root for a square number. You can just make a note of that and you can remember these things. Next, we are going to discuss is the different ways by which we can find out square root of a given number. Okay. So there are various ways by which you can find square root for a given square number. One method is by repeated subtraction. Second method is by the method of prime factorization. Third method is through division. Okay. So when you are preparing for a descriptive type of examination, you need to thoroughly understand and you should be able to solve the problems on finding square root using all these methods. For example, the exams like GPSTR and HSTR, if you are preparing for that exam, you need to write the answers in the descriptive manner. So they can ask questions directly. They will ask you to find the square root through the division method or find the square root through the repeated subtraction. So in that case, you should be following the method which they have given. But for the teacher's eligibility test, since you are answering a multiple choice question, whatever method you follow, you should be getting the answer. They will not focus on which method you have used to answer the question. Instead, you should get correct answer. So here, I am not going to discuss about finding the square root through the repeated subtraction or through the division method. Instead, I will be just telling you the method which I follow, that is the prime factorization method. So we'll just move on to the prime factorization method. So here you go, we have finding square root through prime factorization. So what we are going to do is, we are going to factorize the given number and we will write its prime factors and then we will find its square root. Now for example, you can consider the number 324. Okay. So we will be finding the square root of the number 324 by the prime factorization method. So I hope you are all familiar with the prime factorization method. What we will be doing is we will be considering the number and we will start to factorize, or we are going to start the division by considering the smallest prime number. Once if we are not able to factorize the number by the lowest prime number, then we will proceed to its next prime number. So the division is here. We are going to factorize 324, okay, by using the prime numbers. So 324 divided by 2, we get 162. Again, by dividing it by 2, we get 81, which cannot be factorized with the 2. Now we are going to factorize it with the help of 3. So 27, again we factorize with 3, then we get 9, which is factorized with 3, and again we get 3. So now we can write the prime factors of 324 as 2 into 2, 3 into 3, 3 into 3. Next here, what we are going to do is, we are going to make pair of the numbers here. So 2 into 2 makes a pair, 3 into 3 is another pair. Again we have 2 3s, they make up a pair. Then from these pair, we are going to consider one number each. So 2 into 2 is 2 square, 3 into 3 is nothing but 3 square. Again we have 3 into 3 is nothing but 3 square. Now this I can write as 2 into 3 whole square. Okay. 3 into 3 is 9. 9 into 2 is 18. So this I can write it as 18 square. So 324 is nothing but, it is 18 square. So I can write square root of 324 is 18. 18 is the square root of 324. So here you can see the same procedures, just what we have discussed now. So how we write the square root? It is like this, square root of 324. So that is equal to 18. So similarly, now let's check with the number 48. Okay, I'm going to factorize 48 here, prime factorization. So 2, so this is 24, 12, 6, 3. Now 48 can be written as 2 into 2, 2 into 2 into 3. So now here you can see that all the factors are not in pairs. We have 2 in pairs, 2 in pairs, but this 3 is not in pair. So we can tell that 48 is not a perfect square. When we can pair the factors into perfect pairs, we can tell that the given number is a perfect square. If we cannot make factors in pairs, we tell that the given number is not a perfect square. Now the question is, since 48 is not a perfect square, can we make this 48 as a perfect square? Yes, we can make 48 as a perfect square. So what we have to do is that when we factorize a given number, the factors should be in pairs. Now to make these factors in pairs, what we should do? I have to multiply with 3. Okay. Now to these factors, if I multiply with 3, okay, I'll just write here into 3. Okay. Now I can make pairs out of the numbers 3 and 3. Okay. So what I should do in this case is, I have multiplied 3. Okay. So 48 into 3, we will get 144. So now here multiplying by a number 3 makes 48 a perfect square. What other way we can use is that we can divide it by 3. Why is that? It's because now if this factor 3 is not there, then we have a pair of 2, another pair of 2. Okay. So as you can see here, now what I should do is I have to remove that 3, means I have to divide it by 3. 48 by 3 will make the pair of 2 2s. So now this is 2 square into 2 square. So we have 4 into 4, that is 16. So we get 16 here. Once we divide 48 by 3, now that is a perfect square. So what you can do, if the given number is not a perfect square, do the prime factorization and find out which number is not having a pair. Either you have to multiply with the number or you have to divide it by the number. So this type of question might be asked in teacher's eligibility test, where you should find the square root of given number, or they will give you a number, they will ask you to check whether it is a perfect square or not a perfect square. Or they will give you a number and they will ask you by which number you have to multiply or divide to make the given number as a perfect square number. So I hope you can solve any problems related to this type, okay, by the prime factorization method. So for making this concept perfect, you can solve the remaining examples as well as the exercise questions on this topic. See, here you have so many questions in these exercise which you can solve and make your concepts perfect. Another method which you can use to find the square root of a given number is the estimation method, where you will be knowing that the two perfect squares between the given numbers. You can just estimate what might be the value of the square root for a given number. Okay, this is just an approximation method which you can make use of since you are appearing for the multiple choice question examination. Just from the given 4 options, you need to eliminate 3 and you need to choose the right answer. Where to find square root of a given number, you can use the estimation method as well. So I hope you will find this video helpful. So in this video, I have covered all the important points from the chapter Squares and Square Roots of 8th Standard Mathematics. I hope you will make use of this video in your preparation for Paper 2 Mathematics of Teachers Eligibility Test. Please do like this video, share and do subscribe to our channel without fail. I'll meet you in the next videos with many more informations and important points with respect to the Karnataka Teachers Eligibility Test as well as CTET preparations. Thank you for watching. Stay connected. Keep learning. Take care. Bye-bye.